Right, your lesson for today is a combination of sections 2.6 and 2.7. We're going to be taking a look at the theorems that are in those sections and then giving some thought to how you could prove those theorems. So you'll need to find the pages and it'll be between two sections. I think we actually did skip lesson 2.3 in the sequence that we're doing right now. So deductive reasoning is the process of using logic to draw conclusions from given facts, definitions, and properties. We're going to use deductive reasoning as we think through how these theorems could be created or proven. A theorem is any statement that you can prove as true. We're not going to prove every theorem that we do in geometry, but we will do a number of them so that you get the idea of what's going on. Once you have proven a theorem, you can use it as a reason in later proofs. So that's why the sequencing in geometry is important. You have to have the background to build up to concepts. You can't just randomly stick something in without it being able to be supported. So if you'll find the first theorem, its number is 261, and it's called linear pair theorem. If two angles form a linear pair, then they are supplementary. So as you fill out your notes, what is the hypothesis and what is the conclusion? From what we've been studying, hypothesis is the if part of an if-then statement. So your hypothesis, two angles form a linear pair. Conclusion, they are supplementary. So what that means is in order to use this theorem, you have to have a linear pair. Now you need to know by definition what is a linear pair. And that is a fact that you're going to probably have to pick out from a diagram. So looking for the two angles that are adjacent and make a straight line or have opposite rays with their non-common sides. But in order to use this theorem, you have to have a linear pair. Once you have that linear pair, this theorem can support that the two angles are supplementary. Then another step in the thinking process is, okay, what does supplementary mean? That definition told us that it's two angles that add up to 180 degrees. So if we put all those thoughts together, we can use this theorem and come up with a conclusion that we didn't have before. So give some thought, why is a linear pair of angles supplementary? And if I just think about the diagram, there's linear pair. Well, from this side all the way around to this one, that makes a straight angle. Straight angles are 180 degrees. So angle 1 and angle 2 together would make 180 degrees. The term for two angles that add up to 180 is supplementary. So the sequence of thinking, we can actually prove this theorem. Okay, as you're listening to this, be sure and pause as you need to if I'm going too fast for you to write down the notes. So here's an example problem. I want you to pause and figure out what the value of x is and then substitute in to find each angle. I'll give you the answer after you have worked it. Okay, to find the value of x, the equation you should have used is that those two angles added up to 180 degrees. Solved correctly, x was 27. Substitute back in, 54 and 126, and verify what do you get when you add 54 and 126. Notice that is 180 degrees. Now I've only put in one example on each of these theorems, so if you need more explanation or more examples, you can ask about that tomorrow. Or you could refer to your book, perhaps they have another example. I thought one would be enough, probably. The next theorem is called the congruent supplements theorem. Again, read through and write down what's the hypothesis, what's the conclusion. Now this one with the parentheses part in the hypothesis, there really are two ways you can use this theorem. You can either have two angles supplementary to the same angle or two angles supplementary to two congruent angles. But in either situation, the two angles that you started with will end up congruent, which means they would be the same. So let's think through, and as we're thinking through, we're probably in our mind proving this theorem. Okay, let's just do the first part of it. If two angles are supplementary to the same angle. So I think I'm going to just make a picture. Here's an angle. Let's say that angle is 40 degrees. Okay, so angle A, we're going to say is a supplement to angle B. So if that's a supplement, how many degrees would angle B have to be? 140. Now let's say that we have another angle, C. But we want C to also be a supplement to B, because we wanted to create two angles that are supplementary to the same one. So if C is supplementary to B, C would have to be 40 degrees. So as a result, did we get the two angles being congruent? Angle A and angle C, notice ended up being the same degrees. Oops, C. So we did arrive at the solution, or the conclusion, I should say. So if you did the parentheses part, you would have like angle A supplementary to B, C supplementary to like D. If you knew B and D were congruent, then A and C would be congruent also. That would be the second version of that theorem. So your hypothesis and your conclusion. Remember the hypothesis, that's what you need in order to use this theorem. So in problems that we do, that's what you have to look for. Do I have this situation? If so, I can use this theorem to help me out. So here's an example. I'm going to pause and let you read through and figure out what the answers are. If you started it back up, you can always draw a picture if you want to. The angles that are congruent would be 1 and 3. Because according to the directions, 1 and 3 are both supplementary to angle 2. So this theorem says 1 and 3 would be congruent. So then if 1's 52 degrees, wouldn't angle 3 have to be 52 degrees also? The next theorem is called the right angle congruence theorem. It simply says all right angles are congruent. Now you might notice that that is not in if-then wording. So how would you put it in if-then so that you could figure out the hypothesis and conclusion? So how many right angles would you need? Now it says all right angles are congruent. Congruent means that they would be the same degree measure. So you can't use just one right angle, can you? You'd need at least two, more if you wanted to, but I'm going to keep in mind when you're doing comparison, you're probably comparing two things. So I'm thinking that the conditional form would be if there are two right angles, then they are congruent. If you have more than two, you're just repeatedly using this theorem. So your hypothesis, you need to have two right angles. Conclusion, those angles are congruent. So okay, this one doesn't take a lot of thinking to prove. Okay, two right angles. We've got angle 1, now let's say angle R is 90 degrees. Angle T is also 90 degrees. We have two right angles. We can come up with angle R being congruent to angle T because they both have the same degree measure. Now we really use the definition of a right angle to come up with the 90 degrees, and then we use the definition of congruent angles to get the conclusion. Okay, so your sample here, again, pause so that you can read through and come up with your solution. Okay, so according to the right angle congruence theorem, you should get angle ABC congruent to angle RST. If you were thinking, okay, I know that angle ABC's measure is 90 degrees, that is true, but that's not what the right angle congruence theorem comes up with. That's really what the definition of a right angle says. So there are different things that we have related to right angles right now. So we've got to think which one comes up with the fact that we're after. So this was a conclusion from that theorem. The next theorem is called the congruent complements theorem. Now the wording on this one is very much like the earlier one that was congruent supplements theorem. The only difference is now we're talking about starting with complements instead of supplements. So go through the wording, get your hypothesis and conclusion figured out. Okay, now let's think through it. It'll be very similar to what we did earlier, but you've got 90 degrees. So let's kind of make a list here. Let's say we've got angle A, angle B, angle C. Okay, so the measure of angle A, let's say, is 15 degrees. I want A to be a supplement to B. I want C to be a supplement to B. Oh, whoops. I was using supplement. That was from our earlier theorem. This one's complement. Did you catch that? Okay, complementary. Okay, so what would the measure of angle B have to be? 75 degrees. Those two have to add up to 90. Now angle C, if it's a complement to that 75, C is 15. And in the end, we do have angle A and angle C congruent because they were both complementary to the same angle. Okay, so my example now, read through and let's have you figure out how to answer A and B. So did you get angle B and E are complementary? But notice this is the parentheses part. Okay, we've got A and D being congruent. So those two angles are the ones that angle B and E are complementary to. So this is the parenthesis part where B and E are complementary to congruent angles instead of complementary to the same angle. So if angle A is 52, what's E? Are A and E the ones that are supposed to be the same? No. B and E are the same, A and D are the same. So E should be 38 degrees, which is really the complement of angle A. Okay, now if you'll turn a couple pages in your notes to section 271. This is called the common segments theorem. On this theorem, you really have to have the diagram to help you in the hypothesis because it says given, which is what you have to start with, given collinear points A, B, C, D arranged as shown, so that arrangement needs to be available in your hypothesis. Okay, if segment A, B, and segment C, D are congruent, then you can conclude AC and BD are congruent. How does this one work? Well, it says common segments theorem. Oh, did you get your hypothesis and conclusion? Not only is it the picture, but if you want to match it with the example, the segment AB, segment CD in the hypothesis, and AC congruent to BD in the conclusion, you could do that. Notice how I kind of put it into words. Okay. So the common segments, they actually both, in the conclusion, don't these both have BC as part of them? So what we did, now this isn't completely technical, but segment AB was congruent to segment CD, which means AB's length is equal to CD's length. That's what congruent segments mean. Add the length of BC on each side. That's like the addition property of equality. So AB plus BC is going to give you AC's length. CD plus BC is going to give you BD's total length. That was like by using the segment addition postulate. And if you know those lengths are the same, then segment AC is congruent to segment BD, which is the conclusion that we were supposed to come up with. So when we write a proof, those are basically the steps that would be in the proof. We'll have to do a good job of writing at the right-hand side what the reasons are. I said them, I just didn't write them down right now. Okay, so here's an example that relates to that theorem. Give some thought to what AC and BD are. Not a real difficult example. Each one is 28 because you are simply adding 9 and 19 to get AC. You're adding 19 and 9 to get BD. And they do end up the same length. Next theorem is the vertical angle theorem. Vertical angles are congruent. We will use this theorem a lot. Okay, again, it's not in if-then form. So think about how it would go in if-then form so that you can determine your hypothesis and conclusion. Pause and give it some thought. Write down what you think. Again, how many angles are you talking about when you're talking vertical angles? At a time, you would be comparing two angles. So I'm going to go, the hypothesis is that there's two vertical angles. Again, you'd have to see the diagram, and you could pick vertical angles out without having to be told that there's vertical angles. So that is one that we often come up with on our own. The conclusion, those two angles are congruent, and then we can interpret what that means. Okay, let's give this one some thought. I'm going to give myself some space to work. Okay, so vertical angles would be, for instance, in this diagram, 1 and 3. I'm going to put a 2 here because I want to use angle 2 in my explanation. Okay, how would I convince someone that vertical angles are congruent? Well, let's see. Angle 1 and angle 2 are a linear pair of angles. We know that they are supplementary. Supplementary means they add to be 180, excuse me. So measure of angle 1 plus measure of angle 2 is 180 degrees. Also, if I do the same thinking process for angle 2 and angle 3, they will add to be 180 degrees. I can put those together. They're both equal to 180 degrees. We could substitute. I'm going to do measure of angle 1 plus measure of angle 2 equals. But I'm going to take out this 180 degrees and replace it with something that's equal to 180 degrees. What else is equal to 180 degrees in this problem? Measure of angle 2 plus measure of angle 3 is. So I substitute it. If you look at the equation that I have there, if I would subtract measure of angle 2 from each side, we just learned that would be the subtraction property of equality, subtracting by the same thing on each side. That leaves us measure of angle 1 equaling measure of angle 3. If we have two angles with the same degree measure, they are congruent. Vertical angles 1 and 3 are congruent. If you want to, put some numbers in there. Angle 1 is 30 degrees. Angle 2, to be a supplement, would have to be 150 degrees for the linear pair. There 2 and 3 are another linear pair, so 3 would have to be 30. And you can see the actual measures of 1 and 3 are the same. So hopefully a couple ways I have convinced you that vertical angles are congruent. So here's a related problem that I would like you to work for your sample. Pause so that you can work through and figure out the complete answer. Okay, to figure out the value of x, you should have set the two expressions equal to each other. Now what supports that? It's the theorem that we're on right now. Vertical angles are congruent. So those two angles, notice in the picture, are vertical, across from each other, formed by the same two lines. So to be congruent, they have to equal the same. Solving, I get x to be 16. Now find the measure of each angle. So substitute back in. 7 times 16 minus 28 should be 84 degrees. 5 times 16 plus 4 should also equal 84. All right, vertical angle theorem, as I said, we will use that theorem a lot. And the last theorem for this lesson, it doesn't have a name. Some of the theorems, they just refer to by number. If two congruent angles are supplementary, then each angle is a right angle. So instead of a name, you see this symbolism stuff here? That's really what they're using to shortcut having to write out all the words. So that's an option for you. Referring to it as just Theorem 273 is another option, or writing it out completely. So that notation to me says congruent angles that are supplementary. So if there are congruent angles that are supplementary, then there's right angles, or they are right angles. So you do have to know a little bit about it to even understand what that means. Okay, hypothesis and conclusion. Pause and write those down. Okay, then let's think through two angles that are congruent and supplementary. So they have to be congruent. So angle 1's congruent to angle 2, which means their measures are the same. And they're supplementary. Supplementary means that they would add together to be 180. So we could do a substitution here. Let's take out measure of angle 1 and put measure of angle 2 in its place. So two angle 2's would have to be 180 degrees. Oops. So when you divide, measure of angle 2 is 90. 90 degrees is a right angle. And we could do the very same thing instead of substituting for angle 1. We could substitute for angle 2. So instead of angle 2, we could put angle 1. And in the same way, we get angle 1 to be 90 degrees. So again, the step-by-step is what a proof is going to be like. we need to have each step along the way. So here's an example for Theorems 273. Do you have what the hypothesis requires? And if so, what does the conclusion tell you? Angle A and B are right angles. Doesn't tell you that they're 90, doesn't tell you that they're congruent. It tells you that they are right angles. Look at the wording in the conclusion. Okay, for an exit ticket, kind of a check of understanding, let's have you think through these 3 questions, and then I'll go through the answers with you. Okay, the theorem. What is a theorem? The definition that we gave earlier, I'm trying to flip to the correct page for you. A theorem is any statement that you can prove. How do you determine the hypothesis? If the theorem is written, or you want to write it in if-then form, the hypothesis is the if part. It's what you have to start with to use the theorem. And then number 3, how to determine the conclusion. The conclusion is the then part from an if-then statement. That's what you can arrive at or come up with as a result of it. All right, that should be the end of today's lesson. Find out what your assignment is and work on that the rest of the time.